In this tutorial, I'm going to show you how to configure the analysis workflow that you imported into Terra from DocStore and how to run it on the 1,000 genomes data that you previously imported from Gen3 into your Terra workspace. We start in the workflow section of the workspace, where we landed after importing the joint genotyping workflow from DocStore. This is the configuration page for the workflow. By default, it displays the Inputs panel down here. And this is a list of all the inputs that are expected by the workflow. Some are required, some optional, and in fact, you can go ahead and hide the optional ones because we're not going to worry about them today. The simplest way to use this input configuration form is to type in the actual values that you want to use as workflow inputs in these form fields here. And conceptually, that's very straightforward. The downside is that it might be tedious to fill in manually, especially if you plan to run the workflow a bunch of times on different inputs. So there's also another way to do it that allows you to point the workflow at one of the tables in the Data tab and tell the system, just take the values from this table and plug them into the workflow. That takes a little more effort to set up initially, but then afterward, it's easier to fire off additional invocations of the workflow. It also helps a lot with dealing with very large cohorts. Today, I'm going to show you how to do it both ways, because they're both useful and it's important to understand the difference between them. We'll start with the first option, using direct file paths, which we activate by switching this selector right here. Now, this first option is especially well suited for what I like to call plumbing tests. And by that I mean checking that the workflow works as expected on some predetermined inputs. And that should really always be your first reflex when you try out a new workflow. If possible, run it with exactly the same inputs as the author of the workflow. If they're doing things right, they should be providing example data and resource files that allow you to reproduce their own test case. And by the way, this also helps you figure out what should go into each of these if you have no idea what some of these words even mean. Okay? It's okay to be new and it's okay to be learning. That's why we're all here, in spirit, if not in person. Now, of course, since I said that, I now have to show you that the workflow we made you import does indeed come with a fully configured test case. So you can find that in the original workflow entry in DocStore. You just need to click the link up here to go back to that for a minute. And so now we're back in the workflow page in DocStore, and you can see here under the workflow path, there's a test file path. Unfortunately, this is not clickable, but you can find the test file by switching over to the Files tab and then clicking Test Parameter Files. This is a list of workflow input definitions, along with specific values and file paths to suitable example data. And this includes, for our workflow, GVCF files, a list of intervals, and the relevant genomic reference resources. And all of this is structured in a text format called JSON. Now, you could copy and paste the text from this view into the fields in the workflow configuration form. But there's a better way to do it that's less tedious and less error prone. First, you want to download this JSON as a file to your local machine by clicking this little download icon right here. And now this has been saved to my downloads folder. Now switch back to the browser tab with the Terra workspace over here. And in the workflow configuration, in the inputs down here, find the text that says drag or click to upload JSON. So click this and select the JSON file that you just downloaded. Click to open. And you see that the system automatically populates all of the relevant fields with the contents of the JSON file. And you can see here the file paths are all in there. The GVCFs, the intervals, and the genome reference data. There it is. So make sure to click the Save button up here to save the configuration. And with that, you're actually ready to run the workflow. So let's do that. Click Run Analysis and then Launch. Boom! Workflow submitted. Now you're in the Job History tab, and this is where you'll come to monitor and sometimes troubleshoot workflow executions. For now, however, let's let the machines chug away on this workflow while we go look at the other way of configuring the workflow that I mentioned earlier. So we'll go back to the Workflows tab, where you see now that your imported workflow is listed. Or rather, technically, your workflow configuration is listed there. You can set up different configurations for the same workflow and have them exist side by side within a workspace. In fact, that's exactly what we're going to do now. We're going to make a copy of our original workflow configuration and then modify it to use the data table for input. So click on the circle icon here and select Duplicate. Then give the copy of this a distinct name. I like to use data tables when I want to signify that I'm using the data table mode of input. So click Copy. Now you have your copy with a new name. Just click on that and we'll get to work. So this time we're going to configure the workflow to run using data tables. And the motivation here is that we want to run the workflow on the Gen3 data that we imported. And to be clear, we could still use the first configuration mode. I mean, I could go look up file paths in the table and plug them into the form fields below. But that would be super tedious and not scalable. So data tables are definitely the way to go here, even though, as you'll see, it takes a bit of extra effort to get everything set up. So let's get started. First, we need to switch this mode selector here to use the data tables. Now that triggers the appearance of some new options. Step 1, we have to choose a so-called root entity type. It's a way of expressing which pieces of data you plan to run on based on how the dataset is structured. So concretely, in our case, we want to run on a subset of the sequencing data, and specifically a set of GVCF files from the table called sequencing. So in the drop-down, I'm going to pick sequencing set. Then on to step 2, where we can select exactly what data we'll run on. Now by default, the system offers to include every row in the table we referenced as an input. Depending on how your dataset is structured, that can be a very powerful option to be able to say, just take everything that's in this table, like process all the samples. But in this case, the dataset structure is a little quirky, and one might even say untidy, so we need to make an explicit selection. Let's click on Select Data and then create a new set. Here I need to find the rows with GVCF files, so I'm going to reorder the table. Here we go. Find the files with g.vcf in the extension. And I'm going to select those boxes, those samples files by selecting the boxes. I'll take 3. You could use more or less, but 3 is a good basic test. So I've selected 3 rows. Now I need to give a name to my sets. I can use the default name that's assigned by the system, but it's awfully long and awkward, so I'm going to name it something else. Let's say joint genotyping test 1. There we go. I click OK. And now you see that I have one sequencing set containing 3 sequencings, meaning 3 rows from the sequencing table. And when this runs, it will create a new set named with the name that I put in. So now my workflow is configured to run on those rows from the sequencing table. Now, as a side note, this is fine for small numbers of rows, but I wouldn't want to tick endless boxes for a large cohort. Fortunately, there are other ways to create sets. For example, by uploading spreadsheets, defining sets, and set membership. I'm not going to cover that here, but we have examples and tutorials in the documentation. So, can I run it now? No, not quite yet. We've told the system what pieces of data to process, but we haven't actually told it what piece goes where in the workflow. So let's wire that up now. Look at the fields in the Inputs tab. We need to replace all these direct file paths that are left over from the original configuration with references to the data from the imported datasets, a list of intervals, and the appropriate genome resources. I'm going to start with the genome reference resources because it's probably the less challenging piece, and it will allow us to ease into a couple of new concepts that can take a little getting used to. The data that you imported was generated using a version of the human genome reference that is called GRCH38, or HG38 for short, for human genome. That's different from what we used in the plumbing test, which was an artificially small data set. Now we're working with a real full-scale genome, so you have to find a copy of that build of the full genome reference. Fortunately, Terra workspaces can access preloaded resources that include HG38 references. So I'll show you how to use them. First, we're going to open the Workspace Data tab in a separate browser tab, because we'll be going back and forth between those two tabs for a little bit. So here on the right hand side where you have the list of tables, you see this reference data entry with a big plus sign. Click on that, and in the drop-down, you can select the HG38 reference. Press OK. And now you can see that you have this brand new table called HG38, which is a list of key value pairs with basically a key referring to the resource, and then a value that is the file path to that particular resource. And this is a lot more than what we'll use today, but it's really good to know that this is available in the platform. So now that we have that set up, we can actually just go back to our workflows, our workflow page, and we're going to refresh the page so that it'll be aware of the changes we made in the data tab. So now, for these reference genome resources, I can actually go in and type the special keyword workspace dot. And now there's this list of all the available resources that are in that table that we just saw. That's now available for me to select, and this basically puts a pointer, tell the system, for this input, look up the file path that is referenced by this, this key in the resource table. That's the idea. And I can do the same for the other genome reference files. the dictionary file, and now the index. And there it is. Okay. So now I've put that in, I'm going to save the configuration so it'll save my progress in case anything happens. Okay. Next, the list of genomic intervals to process. There's one included in the reference data table that I just showed you, but it's very large and I'd like to give you a smaller version for testing. So specifically, we put a file with a handful of test intervals in a Google bucket. And you can choose to type in the file path directly in the configuration field here if you want it. Or you can set it up in another special table called the workspace data table. And I'm going to show you how to do that. Okay, so right here, you see this workspace data table. Here the table already exists, but it's empty. So just click the plus sign down here, and you can make up a key name, for example, interval list. Keep it simple. And then here you put the location of the file, which I'm giving you here. And yes, I am a very slow typer. Okay, so I'll click the check mark to save it. And I can click on this to make sure that my file can actually be found. So I didn't make any errors in the file path. The system can find it. That's a good confirmation. So we can go back to the workflow configuration page, refresh the page as previously, and then scrolling down to the interval list, I can use the workspace dot syntax to find my interval list reference. And so now this pointer is pointing to that file that I just set up in the workspace data table. And now you see that for both the genome reference and the intervals, you're now using pointers instead of writing the paths directly in the configuration. In one case, it's a matter of convenience today, of using the preloaded resources, and in the other case, it's more about convenience tomorrow. The idea being that if you need to use that same resource file for another workflow, you can now just point to it. You don't have to put the whole file path again. And if you ever need to update the file path or version at any point in the future, you'll just update those workspace level definitions, and you won't have to touch any of the workflow configurations that point to them. And that's really why we bother to do all this setup, because our future selves will appreciate it. Now comes the hard part. We need to plug in the list of GVCFs that we want to run joint genotyping on into this table right here. How are we going to do that? Well, there are two pieces to this puzzle, two humps to the learning curve. But the good news is that you've already halfway over the first hump, since you're already acquainted with the concept of using pointers to workspace level resources. For the genome reference inputs, you use the workspace.something syntax to point to file paths that are stored as key value pairs in a very simple table. And so we're going to do something similar for the input data, but with a twist. Because this time we need to point to just one of many columns in the sequencing data table, effectively telling the system, for each row in the table I'm giving you, the input you want is in column X. And so the keyword for that is this.x, the syntax. This.x, right? X is a placeholder. And In a simple case where you're running a workflow directly on individual rows in a table, meaning there's one workflow per row, the keyword this right here refers to the table. And so you can just do this dot the column name, where X here is placeholder for the column name, and you'd be all set. However, our workflow wants to see a list of GVCFs. And so earlier, we set up the workflow to run on a set of rows from the sequencing table. So in this case, the this keyword refers to the set. And we have to add the table name before the column name to access its content. So we need to do this dot sequencing, except we're actually going to add an S, which will tell the system to look up items in the sequencing table. And finally, we'll add the column name, for which I'll use an X as a placeholder for now. And so the last piece of this is to look up the appropriate column name in the sequencing table that we're going to put instead of the X. So let's go do that now. We're going over to the data table, looking at the sequencing table specifically. Now, normally, you'd scroll through to find which column holds the paths to the GVCF files. And unfortunately, I'm not finding any. I'm seeing file names. That's a file name, but that's not the location. No Google Bucket file paths that I can see. The closest thing I can see, which is clearly some kind of link, is this object ID with the DRS prefix. And if I click on that, I see actually this resolves to a Google Bucket address. This is the final curveball in working with this dataset. When you imported the data from Gen3, you don't actually get any direct file paths in the metadata in here. You get file names, but not their actual location. Instead, you get this, what's called a DRS object identifier, which acts as a sort of alias for the real file paths. And the good news is that you can pass these object identifiers to the workflow as if they were file paths, and the system will handle everything for you behind the scenes. And really, why am I talking about this? The only reason you need to know about this is because when you're looking for complete file paths in the table, for this kind of data, don't bother. Instead, look for the column named object ID and see if you have some DRS or DRS addresses. And this is actually what we're going to plug into the input field of our workflow. So going back to the workflow tab, we can now complete the reference to the input data by replacing the placeholder X with the column name that we found, object ID. So now this.sequencings.objectID is how we plug in the input GVCFs from our data table into the inputs configuration table of our workflow. And that's it. So we save it, and that's it for the hard stuff. The only thing left to fill in is the call set name, for which you can point to this.sequencingSetID. And that is the name that you gave your sequencing set when you created it earlier on. So this here, JG test 1, this is what's going to be used right here. And the workflow will use this call set name as the base name for the final output file. And by the way, the system will also create a table called sequencing set and write an entry for your new cohort set, JG test 1, with references to the relevant sequencing table rows once the workflow has run. Now, save the configuration, but don't jump to launch the analysis just yet. There's one more panel I want to show you, which is the outputs configuration. One of the really neat benefits of using the data table mode is that the system can automatically reference the outputs of the workflow in the appropriate table when it's done. So in this case, it will put a link to the final VCF file produced by the workflow in the row for that set in the sequencing set table. And to enable that, you just need to click Use Defaults here to use the default column names, which are directly derived from the names of the variables in the workflow, but you can change and use any name you want if you prefer. And now you finally can click, save it, and then you can finally click Run Analysis, and then Launch. And if you're following along, take a breath and realize that you just launched a real genomics workflow on a real full-scale dataset that's hosted somewhere in the cloud. And if you want, you can do it again on any number of other datasets, which is a really big deal. Anyway, we're in the job history section again, and the workflow is making its way through the system. It should take about 45 minutes to run to completion, so I'm not going to record the entire time. But meanwhile, the first workflow we launched should have completed successfully by now. So let's move up one level to find the list of workflow submissions. And indeed, you can see this row right here. This was the first workflow we launched. The one in this bottom row was a test that I ran before recording, and I forgot that it would show up in the job history. Oopsies. Anyway, this right here ran correctly. And here you can see that you can click through and get a lot more information about the execution of your workflow, including details about the various tasks, how they were parallelized, how long it took. I especially like for that to see the timing diagram, which shows the various phases of execution of your workflow. Unfortunately, I don't have enough time to cover all of that today, but we do have plenty of documentation on the websites, including short intro videos on YouTube, and I really encourage you to reach out to the help desk or post in the forum if you run into any trouble with all of this. Now, finally, I do want to acknowledge that some parts of the workflow configuration process, especially for using data tables, can be a little challenging. And to be frank, we're still working to iron out some aspects of the Terra interface, particularly around working with data tables and sets, which can be a bit tricky when you're just starting out. Nevertheless, I hope this tutorial gave you a sufficiently tantalizing glimpse of how powerful this system can be in terms of leveling up your research capabilities, particularly in combination with other components of the AnVIL ecosystem, such as Gen3 and DocStore.